Morning.
Morning, Vijay.
Good morning.
Morning, guys.
Okay, Karthik is here.
Good to see. And I also saw that you invited someone yesterday to the group, so that's good.
Yeah, she's my colleague. She's she has a lot of experience designing, and yeah, she's a very diligent developer.
That's awesome. Yeah, glad to have more people. So I was actually kind of reading through this lesson again and the previous lesson. I think I had some thoughts that I wanted to go through, but I guess I'll save them towards the end. I think just basically it was around, let me see here, I'm going to go back real quick. So first off, like, I know we're reading this book, but like, do you all ever kind of like read the footnotes or references too? Just like scan through them? Not read the whole thing, obviously. Or do you just kind of preview some of these? It's a lot of good reference points here.
Yeah, I think we should. So there's always ideas to, steal from, right? So yeah, did we have anything in this chapter so far that we needed to go back and study separately?
Nothing? No, not at all. Like, I think it's we're in a good place with this past chapter.
Yeah,
I think we kind of glossed over columns because we were trying to rush towards the end, but it would be good at some point, to just look at that again, like in some detail, but that's not now. I think like the pace we're going is fine.
Oh, you're talking about chapter 3. Okay.
Yeah.
Okay.
Because they came up with, at the end, there was like a data queued structure, which I thought was pretty interesting. And, it was just, again, like another way to like compress down data and make it easy to retrieve for a database. So, like after I finished reading through that one more time, I was just like, okay, wow, like, I want to just see some more examples of this stuff. But I think for now, like we're in chapter 4 where we're talking about evolvability.
Actually chapter 3 is missing notes also. So I think we had some notes on LSM, I think, but then after that there was no updation. So I started writing for the chapter 4, but chapter 3 is incomplete. So yeah, that's a pending task. We can just take it up. If you are reviewing, then feel free to update the notion notes also. But I don't know how I'm not able to recollect what is the data cube. I think I missed that class. That's why I don't know what that is.
Yeah, that's what I was saying. Like maybe at some point, we kind of go through it again, or this last part here, not the whole thing, but and then one other thing, here's data cube. It's on this page here. You can see how it works. It's also called an OLAP cube. It basically, keeps track of the columns in like a 2x2 matrix. So you have one column date key and one column product SK. And then it's easier to just kind of, this is like, I guess when I got to this part, as I was reading through it, it was talking about materialized aggregates, like count, sum, average, min, and max. And so like, I don't know if you remember views from SQL, but view is basically like a predefined set of an SQL command where, it joins some tables together, and then you just, the next time you want to see all that, you just use the view command, right? Like where you just say select from view. So they were saying it's kind of like a cache, like a materialized view, and the way they store that data is basically a copy, and then it's one way to kind of like, retrieve this data faster, right? Because like that's what this past chapter was really all about. It was about big data and retrieval, and all the different data structures that we were seeing and exposed to were just ways to basically show us like, okay, this is how you can retrieve data faster, given this type of database or that type of database. And then going into the last part of this chapter where we start going into OLAP, right? OLAP is basically huge data warehouses, right? When you just kind of imagine it, it's just like super huge. So just trying to traverse all of the data, especially if you have like petabytes of data, is very, very time consuming. And so like they need like these kind of, extra optimizations in order to be able to traverse that data, like what we saw with the columns and then the data cube over here. So storing in memory, like some of these aggregations.
Got it.
But yeah, again, like I was talking to Karthik one time, and I think he was just kind of like saying, we don't need to get bogged down in details of implementations of stuff. I think it's just fair to just kind of understand like the different type of systems out here, and like the ultimate goal is like choosing one. So that made me start to think about like, your question was, we tend to do a lot of reading, and then we haven't really been doing like sort of exercises or like, the stuff that you saw from like the Alex Shu, I think, book. Let me just ask you this, right? Like if we were to finish reading this book, like let's say it takes us, 3 to 6 months, where do you see us at the end of that? Like, do you think we will, be more ready for a system design review, or do you feel like we'll be kind of like just asking more questions then, like, okay, we read all this stuff, but now like we're even more like confused because like we realize we don't know a lot, right? Like, do we need to know every single thing in here, or what is that particular interview thing going to be asking us to do?
I think, for me, we should take away the ideas. In this chapter, right, for example, we're talking about protocol buffers. So and there are different binary encoding schemes, right? The protocol buffers, a thrift, and also each one has some they have different ideas on how to define the schema, and like basically the pros and cons of each. So going through that thought process, and you don't have to remember thrift and all those names, but I think understanding the thought process, what is the best compaction that you can, like how best can you reduce the data payload size. So what is the best possible, and like so being confident about when you're answering those questions, I think I think at every chapter we should probably do a takeaway, like what we did last, did you do? I think Sadhana gave us an overview, right? Like we should have something like that after every chapter. So, and also notes, so that we can go through it right before an interview or whatever.
Yeah, exactly. I think like if we have more of these kind of review sessions where it's not so much like just we're reading from the book, but like maybe just we're kind of like adding our extra thoughts or something like that might help. How it could type.
I mean, revision is key because the content is dense, right? So if you don't go recap, it will slip through. So I think, we should, after every chapter, we kind of go over the previous chapters, kind of help us retain what we read.
Okay, sounds good. All right. Yeah, and if anyone else wants to add to this, just feel free to, you can say it now, or you can go through this later, like when we finish this portion. So I think we had Ramya read last time. Ramya, do you want to continue reading, or do you want to pick a different person?
I can continue reading, but if someone else wants to volunteer, I'm fine with that too.
Well, the volunteer part let's just drop that. You would say popcorn. Just to encourage people to read or to like review.
Yeah.
So,
I read the entire chapter, so I can finish the review of this chapter.
okay.
Yeah, so just before you go, so let's kind of review what we read so far, right? So so basically there was this 2x2 matrix that you were gonna come up with, Ramya. Did you have that up? And okay, so like maybe for the next class, right? So yeah, so what we read so far, I'm just reading from my notes here. So as the data, so there are two types of evolution that we should consider when designing systems. One is the data evolution, another is the application code itself evolving, right? And then and there was this backward compatibility and forward compatibility that you would have to both sides, both the data side and application code side, that you'll have to think through. So and the first part of the chapter was about text-based encoding, like the author talks about. So basically what encoding in this chapter he's referring to actually is serialization, what we call, at least in Java, we call that serialization. Java has a native serialization, which is pretty inefficient. It kind of bloats the data. It kind of tries to persist metadata more than the actual data. So it's kind of you end up with a serialized format, which is bloated and it's not very efficient. So in order to support this platform agnostic serialization, we have generic text-based serialization like JSON and XML. JSON and JSON, XML, and the binary variants, right? So they have their own, each one has its own merits. JSON is like very human readable, but it lacks schema enforcement, and it also does not support some long float data types. Right, so XML is a little more like you can define your XML schema and it can enforce that schema for you, so it's a little more safer. And did I miss it? Yeah, and then going to the binary encoding.
Hey, Amulya, there is a Twitter example given over here, like why their API has to return that same number twice in the JSON block, in the JSON response. I think it's on this page, on the page number 188 at the end. I think it's highlighted. If you can go over that as well.
Yeah, so they say the JSON returned by Twitter's API include tweet IDs twice, once as a JSON number and once as a decimal string. I think this is a workaround. Yeah, the workaround for the fact that JavaScript application, basically the JSON as a schema technique, it does not support it does not natively support integer format. Is that what the floating point number, I guess? Yeah, because the IDs tend to be really long, right? So it cannot accurately express that. Is that the idea, Akanksha, here?
I believe so, yeah. So I really do not understand it, and that's why I'm asking you this question. I tried to read it, but I couldn't understand it correctly.
They're saying tweet IDs can be more than 2 power 53, and in JavaScript you do not have a precision or a higher precision support to parse numbers greater than 2 power 53. So you have to send that number, which is more, whatever the tweet ID is, more than once, like as a string, so that you don't lose the precision of the ID.
So are we sending it in parts, like sort of?
If you send as a string, it is just a once and string, right? It captures completely.
So
we are sending it as parts. 2 parts.
2 parts, yeah. Okay.
Yeah, but like but if the JavaScript that's reading that JSON cannot parse 2 power 53, then it's anyway in trouble, right? Like, yeah, I mean, you can represent the ID to like break it up and kind of send it as 2 separate IDs. but it's up to the services to read that accurately. So if the reading application is not able to read 2 power 53, then like, how is the problem solved? Yeah, but I think it's less of a problem. Oh, I think is that because the front end code in JavaScript is not able to yeah, I think that's what it is. The front end JavaScript isn't able to read the entire thing. I think it's less of a problem with JSON and more of a problem with JavaScript applications, right?
Yeah, and I've passed the link here, to that particular thing that he references. So that was reference 10. So there's a link to this Google Groups. And it says that, here he talks about JavaScript cannot support numbers with more than 53 bits. So maybe it seems like it is an issue with JavaScript. This can be easily examined by running a command similar to, this big number 2 string in your browsers, and then console logging the response. So in your browsers, or by running the following JSON snippet. So.
Okay, Snowflake as a service we will be using to generate unique tweet IDs, and the tweet IDs are 64-bit unsigned integers.
So you can see like what happened here. It says 21, but here it became 20. So that's the losing of precision right here. So it's definitely something with JavaScript.
Okay.
So to allow JavaScript and JSON parsers to read the IDs, we need to include the string version of any ID when reading in the JSON format. What this means is status, user direct message, and save search IDs in the Twitter API will now be returned as an integer and a string in JSON responses. And so that way, like, they can compare, what it should be to the JSON parsed version, I suppose. But
so because you lose precision, you want to kind of also pass it as a string, so that you can kind of correctly arrive at the ID.
correct.
You probably do some comparison and kind of, okay. That's a good reference link. Thanks Vijay for sharing. Yeah.
Yeah, for sure.
Okay. Yeah, going back to, did that answer your question? Yeah, Akanksha, maybe we should read that back, and then like next class we can discuss if there are any doubts.
Yeah, partially it got answered. Yeah, I'll read more.
Yeah, and then the binary encoding. So when it comes to binary, so there are ways to encode JSON text as binary data, and this is there are libraries that natively support this, like Bison and Message Pack. Basically the text is represented as binary here in these formats, and the way to do the binary formatting is you have to define the schema first, and then encode the actual data using that schema. So that's what, so that diagram on on page 117, I think the next, yeah, this one. So in this diagram, we are representing that username, basically the field name and the value. So message pack is not super efficient in the sense that it stores the actual column name along with the data. I think, yeah, that is, we could do better. I think the next thrift and protocol buffers, they skip this storing the column name. They just store the data and have codes for each of those attribute names, like username is given, like let's say 1. And so we don't use the entire username, we just call it 1. I think that's where we stopped last time, Ramya.
Yeah, we finished thrift and yeah, protocols, and now we have to, I have a physical copy of the book. I don't know what the page numbers are same. We have to start field tags and schema evolution, that paragraph.
Okay, field tags and schema evolution. I found it right here. Perfect.
Great. So what the next section talks about it for the both protocol buffer and the thrift, if the schema evolves, how do we take care of changes? Here we talk about two changes. Your old code, so there is a schema change. That means you will have new instances of the data. When you are doing rolling upgrade, sometimes you will in a cluster, few nodes will see a new schema and a few nodes will see an old schema. So you will have data written out by a new schema and a data written out by an old schema. Similarly, the reader of the data can still have the old code, and the reader of the old code can potentially read new data, and a new code can potentially read an old data, right? So these two concepts are called, I'm just recapping, forward and backward compatibility. Ability of a new code to read data generated by an old schema is called backward compatibility. Ability of the old code to read data generated by the new schema is called forward compatibility. Given this background, we'll talk about what happens when we change the field tags, right? In both these protocols, we see a field tag number is used to track the actual fields like 1, 2, and 3, and they have some increments. So what happens if a field value is not set? It is simply omitted from the encoded record. Because as you see from the after the field tag, you have a type tag, right? When you have a type tag, it should follow with the length. If the length is 0, that means it is omitted, and you can have some missing fields, and it is totally possible to support missing fields. Okay, so
you make the new fields optional, right?
New fields optional, yeah. And suppose if you wanted to change the field names, you can totally do it because you are not encoding the field names. You're just encoding the field tags. So if you want to change the username in the example to first name or a last name, you can totally do it because tag is what you are tracking in both these protocols. The next point here is including a new field with the tag number.
So
Okay.
the tag number is one that is identifying a field, right? Like, let's say username is given a tag number.
Yeah, but that username in your schema, you can change it to first name. It doesn't matter.
Yeah.
That's one change. Next is if you want to add new fields. Now you have a first name, you want to add a last name. What happens?
No, but like to your previous point, if you just change the username to first name, then it will break backward compatibility, right? Because your old records thought the tag number 1 is username.
Yeah, but your code is not using, you're not using the actual schema, right? Your encoding and decoding logic actually uses only tag numbers. So as long as you have the same tag number and you change the field names, that is both forward and backward compatible. The parser.
Yeah. Field names can change. Yeah. You can, instead of calling small username, you can call it capital user, this camel case username, it won't break anything. But you cannot completely call username with some ID. You can't just replace the actual content with something else. Yeah.
Yes. So now let's say we wanted to add a new field. You have a first name and you wanted to add a last name. When you add a new field to the schema, you have to ensure that you assign a new tag number. This ensures that I think this maintains forward compatibility. Old code can read records that were written by the new code. Because it's
because the whatever the old code thought were the tag names, they still exist, right? You cannot remove. You're not removing it. Yeah.
The new tags are ignored because after new tag you have a field length and the parser is set up to ignore them. So it supports forward compatibility.
So what if we want to remove some field for some XYZ reasons?
Excuse me, which field? If you want
any field, for example, we have introduced it by mistake. Okay, so you're coming to that.
Okay. Yeah. So you can remove a field. So as you can see from the schema, the fields can be both optional or required. And we cannot remove a required field, but you can remove an optional field. That is both forward and backward compatible. Because optional field, the parser is set up, okay, that can be null. So if you remove that, there is nothing, the parser can adjust accordingly.
Yeah, I mean, if you just introduce something by mistake and so basically you should be careful when you're introducing the required attributes in the schema. I think
At least required fields in the schema.
Yeah.
They say that if you want to add a new field also, you cannot make it required because that would break old code.
Yeah.
Cannot do this new thing and it breaks some compatibility again.
I use this. I use thrift in one of the projects, and initially when we started, it was also my first time using it. So when we started with it, we made most of the things optional, and as we made changes in the thrift definition, like what Ramya was saying, we introduced everything with optional. Wherever we were not sure, make things optional because it also broke things for us. Like the compatibility issue came for us. So yeah.
Yeah, I think it's not a problem specific to this binary encoding schemas. Like even with the schema-less DDB stuff, right? You introduce any attribute and your application code is trying to read that data. And if a field is missing, you either populate it with the default value or just write your application code to ignore it. I think the idea is same, like what we had in that NoSQL databases. How you introduce an attribute there is just basically the same idea.
Yeah, that's a good one. So the next section talks about data types and schema evaluation, right? And I think data types is a dangerous zone. You cannot simply make we can make a 32-bit integer to 64-bit integer, the higher precision, but you cannot go the other way because then you will be losing information and you'll be losing precision in that case. That's what they say. So what is possible and what is not possible? The other detail they wanted to point out here is protocol buffers does not have a list or an array data type. So they simply have repeated fields. And this repeated field has a nice side effect in the sense, if you change something into a repeated field, if you have a singular field or and you change it to a repeated field, that will be casted to a list of length 0. So the compatibility issues are taken care of in that one. It won't break the code. So the new code reading the old data sees a list with 0 elements, and the old code reading the new data sees the last element of the list. So that helps with not breaking the code, but the side effect of old code reading the last element is not probably what you desired in your application. Given this,
no, wait, what was that? So basically, the effect is that when you introduce a repeated marker, it's basically repeated marker is basically a general case of optional. Optional is a specific case of generated where the number of times it's repeated is 0, right?
Yeah.
So
alternative for list because protocol buffers don't have a list. So you have to use a repeated marker. So let's say you have a type field with an integer, right? You can mark it as a repeated integer. If your schema can evolve to a repeated integer, right?
And what about this compatibility stuff? New code reading old data.
New code reading the old data sees that as a list of 0 elements or 1 elements. If it is an optional, it can be present or need not be present, right? So it sees a list of 1 element. So changing it from a primitive to list is also compatible.
Okay.
In all buffers.
Right.
But the old code reading the new data, now it was supposed to have only a primitive, read only primitive type. Now it is reading a list. So what that means is it can hang on to only 1 element in the list, and protocol buffer decided it will hang on to the last element of the list. So your application behavior might be intended. We don't know if that's the intended behavior, whether they want to hang on to the last element of the list or the first element of the list. Just that the code does not break or fail grossly here.
Okay.
The last sentence here, old code reading new data sees only the last element of the list. So this can have unintended side effects. Okay, next we'll go to AVRO. AVRO is like between both thrift and protocol buffers.
Ramya,
Yeah.
so before you proceed to AVRO,
Yeah.
when would you prefer protocol buff versus thrift?
Depends on the application you are doing. One is from it depends on what you wanted to encode and how you wanted to encode. All this encoding process is internal to an organization, so whichever meets your needs, I would say at this point.
So I think support is there in all languages for, so there is the schema definition language for each of them and the code generation tools for each of them. So yeah, maybe the support for the, like how much support is available for each of that, and
Considering whatever language you're doing, it's given like the libraries are present for thrift and protobuf. What are the other advantages of either of them? Over other
Advantages.
The nested list, right? I think thrift supports nested lists because protocol buffers does not support lists, and so you have this hacky way of doing this repeated marker thing. But for thrift, it natively supports the nested lists, and hence it also supports nested lists.
That's one thing. Okay, that's one other data type that is supported by protobuffs.
And there is also some, I don't know if both are similar sizes. After encryption, how much is the compression?
Yeah, like the after compression size.
Yeah.
I think protobuf is better as compared to thrift. That's as far as I know. I don't know.
Yeah,
that's what I've heard.
Yeah, thrift is 59 bytes and thrift also has a compact version which has 34 bytes and protobuf is 33 bytes. So it's not quite different.
Okay.
So this all actually leads me into that question that I was asking at the beginning. Like, so much of this stuff is stuff that, I mean, like maybe some of you have used, but like, I don't know if everybody here has used this stuff, right? So is this part of like the requirement to know like these technologies like later on? Should we be investigating these technologies as part of this group? Because like you can read this book, right? And you can say, hey, I read the book. But then if people ask you, okay, so, what's your experience with thrift or AVRO? Are you going to say, well, 0? I just read a book about it. I don't know, like, what's your take on this?
My take is like, there are a lot of technologies and you can, whatever experience you get is from whatever you have hands-on experience on, but it will be good to know, okay, there exist some things. If a need comes in my future project or a future role, I know I have the where to look for. So knowing something like AVRO and thrift exists is a good thing.
Yeah. I mean, it's not possible to work on all these things. I don't have any experience with this thrift or protocol buffers. So that brings me to that question, Akanksha, why did you have to even use this binary encoding? Why wasn't JSON enough?
Yeah, I started with so we were implementing Kafka and started with JSON, right? And there were other teams also consuming the data. And so what happened was there were other teams, their code was in PHP, our code was in Kotlin, and we wanted something like language agnostic, right? So whatever binary, we didn't want, if tomorrow if I want to switch from Kotlin to some other language, this whatever encoding is happening, that middleware layer, it remains the same, right? And I can move my code application layer logic to a different language. Maybe I want to switch to Go, so I can do that. And still this middleware part remains the same. Also, as compared to JSON, it is much lightweight and the network bandwidth is much faster. So those all things came into play, and eventually, and then we are moving to next one, AVRO. The other team, when we implemented thrift, but the other team, when they implemented their project, they used AVRO for that, and AVRO had more additional benefits, but we'll go over that.
So basically the main, so the middleware being same should not be the concern with JSON also, right? Because like JSON has no language specific stuff in it. The other thing by which you said, which was the lightweight aspect. So when you are concerned about network payloads, getting bigger, or like you have to make multiple calls because your response sizes have met the maximum payload size or whatever. Is that the reason why you would want to move to this this thrift and protobuffers, or is it for more binary, like non-text representations of stuff like maybe images and stuff? Is that
No, we did not use it for images. It was all payments-based data, incoming data. So it was
okay? So it's also probably secure, right? Because you're
probably secure. Nobody is able to read your data, right? And and the other part was what you were saying was, I remember there was some like, so thrift has multiple libraries available, and whatever language you are using, right, it supports, you can encode in using that. But with JSON, problem was that the you cannot we were not using in JSON. Also compression is available, but we did not explore that part. But I am and we did not compare how thrift compression is compared to JSON compression. So I cannot answer that, but for sure, I mean, thrift was much more lighter as compared to JSON, because I was the one doing this part in my team, so I remember that.
okay. Okay, so lightweight in the sense that in network, because if you just did JSON serialization, right? I think from the application performance perspective, it doesn't matter whether you're using JSON or any of these binary encoding formats like this protobuffers, because at the end of the day, it has to be converted into the actual object, and like you have to kind of construct objects out of it. So I think for application, it's the same, and you get the added benefit of having lesser payloads. Yeah,
I think you're right. So tomorrow, today I'm using Java, and I'm passing a JSON stream. And tomorrow, if I'm using Go, and I'm passing a JSON stream, so it would remain the same, right? I mean, nothing changes there. So
yeah. Okay.
So the thing is, a language agnostic property existed even before JSON, right? In an integration world. Think of like early days, right? I don't know, probably you guys have used it or not. The very context of a service and language agnostic started with XML back in days, right? Any service, web service that was exposed, it used to be XML. So that like any client in .NET or any language can parse it and be able to use it, right? That was the first early generation. And even before that, there existed RPC and CORBA days, right? Then we moved into XML based, right? Where you had a means to define validation on a particular payload, right? Input payload using schema. There is a concept called JAXP in Java where you define a schema, right? It's pretty much like IDL in your protocol buffer. So you can define conformity of your payload. You can do all those things even before completely going over the payload, right? But SOAP and the communication protocol for XML communication on the integration layer was SOAP, right? Over HTTP. Now, what JSON made was like eliminated all those like, extra layers of headers and stuff in the TCP layer. So it made it lighter than XML technologies. And the integration was much more easy. Now, going back to, again, protocol buffers, I would even say it's version 2 of RPC, even before XML. And it's like lighter payload when it travels over the network, right? The latency is less, high throughput. Why would you use thrift? Maybe not just for language agnostic thing, because everywhere language agnostic thing exists. The use case for thrift specifically is machine-to-machine integrations, right? Not web to API integration. Like, let's say if you have a web application, preferably you would like to have JSON because all these web frameworks are built to encode and decode JSON. But any machine-to-machine communication, or even like for example, if the client is a mobile phone, right? Any mobile client, you would prefer to use thrift because as a mobile client, you don't want to call like 5 or 10 services, right? Back and forth. So everything is like compacted in a single call. Everything is done and stored. That's why like in the whole GraphQL, everything came about, right? And a different school of thought is this RPC based protocol buffers. And protocol buffers also brings the capability of schema validation by defining your IDLs, right? Your payload, input and output payloads, right? Request response payloads. So those are the main properties. But of the main reason why would you use thrift is like it will auto generate your client SDKs for different languages. So that like as service publisher, right? You are a service publisher and there are multiple consumers within your team or external. You can give them the SDK in the respective languages as and when you iterate. So it's more of an automated build system release management thing. So you can just give them, okay, this is the latest version of the SDK, which is supports all the nice things that you guys talked about, backward, forward compatibility, updated. This is a new service, so you'll be able to use this and get about doing it. Had you gone with JSON, like someone has to generate this SDK, right? It's not out of the box, right? You need to separately generate, but these protocol buffers have the capability to build that client SDK by themselves, if that makes sense.
Mm-hmm.
So when you say SDK, like you're talking again about like machine to machine. Is that kind of like what you're saying here, or like?
I mean, like let's say if you expose a service, right? A simple service, say hello. I know I can, if it's a JSON structure, I can just go on the browser and hit it like I would see the JSON, right?
Right.
Which is okay in the browser. But if you were to call it from some other service, right? Like Vijay has a service, Amulya has a service, Amulya has exposed it, and you are a consumer of a service, right? And a system has to do, so somewhere you have to write that code to go, okay, this is the URL, this is a protocol, get protocol, and this is the JSON. Once the JSON comes, you define that object, decode and unmarshal that object so that you can look the properties of that JSON, right? The property probably has name, age, whatever, right? In the payload. So you will unmarshal it. So it's called marshaling, unmarshaling kind of a technique. So you would do that, right? Or encode, decode. So that you still need to have that SDK. If you don't have it, like you would build that SDK sort of, right?
Right.
The REST API and what kind of a payload, decode. But what if somebody gives you that SDK library, just like, hey, add it in your whatever language that it is, right? If it's a C#, add it in your NuGet or Java, Maven or Gradle, and then that library is available, and then you just need to use that library's, whatever class object it is to call that REST API. The object is defined, the input payload, output payload, how it's going to come, everything is defined for you. You don't have to engineer all those things, right? So back in days, somebody would give you integration documents, right? Oh, the document, Word document, or everything would be there, and then you would go and do this engineering work. But Thrift, by default, like you can generate these for different languages in itself. Yeah.
Okay.
Wait,
All right.
So in protobuffs also we can do the same thing, right? I mean, I've not used.
Yeah, that I would imagine that would be possible with the protobuffers too, right? Otherwise, how can?
No, I'm talking about protobuffers only. All the protobuffers, these things can be generated by default. Protobuffers or Thrift, they're all the same concept. One is from Facebook, another is from Google, right? But the concept is it's communication is over RPC. But if you integrate this with let's say a front end application, you build a protocol buffer service, integrate with front end, you can, right? Not out of the box it brings, but there are different libraries which will help to do that. It becomes a little tough to debug it, right? When you go on the web console and you can see the request response, what is the request and response payload in a JSON, which is more human readable, right? Protocol buffers are all binary. You can't debugging what it gets a little hard, right? If you integrate with a web application per se, front end application, yeah.
So basically, the serialization is not not limited for REST API transfer. You could basically use this for persisting to files or persisting to the DB. So it's not. I think like the point you made about mobile networks, right? Like for example, WhatsApp, when you are kind of working on a reduced bandwidth, you want to reduce the payload size. And given that the application has to do similar amount of work, whether it's JSON or binary, to kind of deserialize into objects, it makes more sense for such mobile exclusive apps to opt for these protobuffers or thrift, thrift, yeah. Yeah, it's a good point about mobile apps. That I missed. Okay.
High throughput, low latency requirements, you definitely can use thrift, right? Thrift brings its own challenges in the build system, the thought process and everything. But for most part, like everything client and server is auto-generated. So leaving you with a higher velocity of deliverable, right? Just focus on the business logic and let us on the framework part worry about the rest of the things, right?
Mm-hmm. Yeah.
So I shared a link here for a protocol buffer Java tutorial, or you can pick the language you like on the previous page. But that said, it seems like it's got like a good example here. Maybe, for next time, if you want, before next time, you could try doing this example and somebody here could like explain what this was about.
Yeah.
I'd be happy to do that, actually. Or if anyone wants to work on it with me, definitely.
Sure, yeah, we can all read it. So basically now, given this reading, right, that we have done, like if you were to design something like a WhatsApp, right, where you have to have fast response times on a lower bandwidth system. First, so the choice of protocol would be like, remember we had this discussion about REST versus RPC versus GraphQL, where where GraphQL, you kind of select what attributes you want. So your payloads are naturally smaller. Basically the server is not dumping you with all the attributes that are there on a particular resource. So you could do that and also do this binary for encoding. That way your payload is like super micro size. So I think you can achieve good performance when you apply both the techniques.
Actually, that's pretty amazing when you think about it. Crunching all this data down and making it like really, really small and easy to like use for the mobile phones. It's pretty cool. So, okay, well, let's go ahead. I think we've got 10 more minutes here. Do you want to get through AVRO as well?
Yeah, I can quickly get through AVRO as well. So AVRO, whatever we learned before, it's another binary encoding. And it's one of the most compact binary encoding of all the schemes we have seen so far. The reason being, when it transmits data and when it encodes, it doesn't transmit any tag number or the field names. It just transmits the values. It just encodes the values. Here, as you can see, there is an ideal where you can specify two schemas. We can specify a schema, but we have two schemas, one for human editing and one for JSON. I've not worked on AVRO, so I don't know why they need two schemas, or whether user specifies just the human editable one and the second one can be auto-generated. I'm not sure. Akansha, do you have any inputs on AVRO, why they need two? Or
No, I did not use it. Other
okay,
people used it, but I know this is better than protobuffer.
yeah, it's
well,
like,
I think the reason they have both is order matters, right? In AVRO, because there is no column name or column tag, right, to indicate what data it is. So you need to figure out the right order for the reader. Basically, they need to have, so basically for a reader to actually deserialize it, it also needs to look at the writer schema so that it can put both together and correctly interpret it. So for example, right, I think in the next page, there is this reader to writer schema mapping.
yeah, that is because the readers and writers can have different schemas, and the schema resolution, whenever reading happens, they use both. But here they don't exactly specify why do you need two versions of the schema. One is in the ideal and other is the JSON representation. That's
Oh,
something.
okay. That I don't. Okay.
Yeah.
Interesting.
So
Yes,
I don't
okay.
know if one is auto-generated from the other and it's easy, or the user has to
Yeah,
learn
that must be it. It says one is human editing and other is machine readable, right?
equivalent JSON representation. So yeah, probably it is auto-generated. I'm not sure. Yeah.
Yeah.
In AVRO, it's compact of all protocols. For the same message we have been following in the entire chapter, it uses only 32 bytes. And as you can see, it uses variable length encoding. This is another concept we briefly introduced in the previous chapters, where if it is a 64-bit integer, if in a 64-bit or 32-bit number representation system, you always use up all the bits to represent a number, irrespective of the number is very small or it fills up all the bits. Variable encoding, like you use only the required number of bits and it helps to pack the numbers in a more compact way. So in AVRO, there is a writer schema and a reader schema, right? So writer schema is what the schema writer used to encode the data, and a reader schema is what the reader uses to decode the data from. AVRO says they need not be the same, but they have to be compatible. So they have this layer during reading, or a middleware, whichever reads which reads the records and does the decoding. It can do some sort of schema resolution. So if you go to the next page, yeah, here it is all says you can have a reader schema and a writer schema, and both can be different, but it has to be compatible. That's it.
So compatible meaning the same data fields should be the same data types, and you should not have missed any required fields, stuff like that.
Order can be different. Username can be the first field or a last field. It doesn't matter. This is resolved because it knows, okay, in my writer schema, username is my first field, but in my reader schema, username is the third field. So it can resolve. Then if the code is reading data, encounters a field that appears in the writer schema, but not in the reader schema, it is ignored. So you can have something which can be, your writer schema can evolve and add a field, but the reader schema need not have that field and it can still read it. But if the writer schema does not contain a field of that name, it is filled out with a default value declared in the reader schema. So you can have fields in the writer schema and you need not have the fields in the reader schema. That case is covered. And if you have a field in reader schema, but you don't have that field in writer schema, it is just covered. That is just pre-filled with some default value. So that's why the schema resolution.
Tracking, right? I think one step back. So basically, AVRO is the most compact way of encoding because it skips the metadata. Basically, the column, nothing. There's no information at all about what columns or what like use. It has only data, nothing else, right? Now, how do we define what we are reading? How do we control what? Like, how do we know what we are reading? It is by using the schemas, right? That's the protocol kind of a thing. The readers and writers, they have this. So basically, when you don't have any metadata, in the
process metadata also, like as part of your record, right? When you save it, it say, okay, it is based on this metadata version number 2.1. And so when somebody is reading, they will have a schema on their own, and it says, okay, it was written using metadata version 2.1. And you can go and fetch the metadata for the version 2.1 or the schema for the version 2.1, and they can do this comparison and resolve these issues. Okay, now my field order is changed. Okay, how would I read it? My field is dropped, so I can just ignore it. Or a new field is there in my reader schema, but that it is not there in the writer schema, so I'm just going to populate with the default values.
Got it. Yeah. So basically, instead of repeating this column information, metadata information in each record, we kind of put it in separately in a schema file and let the record content itself only focus on the value.
Yeah. And if you think about it, like if you are transmitting like if you're writing to a database, right, and you are encoding and writing to, or you're encoding and writing to a disk, you need not store schema with every record. So normalization here.
Right.
And simply when you are transmitting, you can just transmit the bytes, and there can be a database which versions these schemas, and both the reader or the client and server can have access to that same database schema, and they can read common schemas from there.
Mhm.
Next, schema evaluation rules. Okay, what does forward? So for schema evaluation in AVRO, right, default value is the key to compatibility. If you don't supply a default value, then the compatibility totally breaks. So that's why they say forward compatibility or backward compatibility, you should have some default value.
Mhm.
Then, okay, if you look at the AVRO ideal definition itself, favorite number, it's a union of null or an int, right? That means if it's an int, it always have to be supplied. If it is a null means it need not be supplied. In previous cases, in languages, right, we can like string can point to a none in Java. Here it has to explicitly, we have to say if it is a string or a null. So this is to differentiate, can it have null values? So this is like a more explicit schema definition for AVRO.
Okay, sorry.
More verbose.
Are we saying favorite number is nullable?
Yeah, favorite event is nullable. Yes, favorite number is null.
But that was also possible in
Sorry.
protobuffs. That was also possible in protobuf and thrift, right? We had optional, right?
Yeah, but we didn't have typing on that, right? Extra metadata typing saying it can be a null. Here we are explicitly saying it is a null.
I think what they're saying is if you want to represent null, if you skip it, it could be either that it's not set or it is null. But if you actually set it as null, then it means that somebody wrote it as null.
I see. Okay.
Yeah, that's about AVRO. It's like a compact version of everything else, and you don't transmit schema and you have these schema versions, right? Then the next thing talks about, but what is writer schema, right? You can go to the next page. Yeah. So how do you save these writer schema? Like if you want writing to a disk, if it's a large file with a lot of records, you write the schema separately, and your schema is not repeated for every record. So this saves, there is an AVRO container file or an AVRO object file. So when you write it data in an AVRO format, it automatically takes care of adding schema to all the data. And that schema is only saved once. The next case is what I talked about previously, database with individually written records. In that case, you can have a column in the database which points to the version of the schema. And sending records over a network connection. Here, the client and server negotiate what schema version they will in order to talk to each other over their session or over their connection lifetime. And they establish this beforehand before even transmitting data. So in that case, it is preset and users know what version of the schema they are receiving or what version of the schema they are sending. If they cannot establish this contract, probably they won't fail and they won't even establish a connection.
But that's a significant complexity, right? Now you, along with encoding, now you have to design your API also to kind of implement this handshaking process.
Yes, yes. If the reader doesn't know about the writer, right, or it's not compatible, then you cannot send data and it will not understand. So yeah, it's very complicated in RPCs.
Yeah, it's also more, isn't this more complicated? We are maintaining two schemas now, a reader schema or a writer schema.
That's an advantage. So we are trading like a complexity of resources, right? You're saving things, but we are our transmission bytes is much smaller. So faster transmission, but more memory for the entire system because we are versioning all the schemas.
And that's why AVRO never took off big time in adoption, even though it was better, because the ecosystem and it pretty much like it's deja vu going back to old days of XML having multiple versions, redundancy, and it brings its own confusion, right?
Yeah, so all in all, if you want a simple reduced payload size and you don't want to deal with this versioning headache, you basically have to, so the simplest binary encoding form you could use is BSON, right? Like the first JSON binary encoded. But then, although, I mean, it gives you some benefits in terms of the actual payload size, but it does not enforce that you have this schema definitions. Yeah, I think that's probably least effort and reduced pace. Like if that's your criteria, then I think you probably want to use I think the dumber version is of course a plain JSON. If you want to be a little smarter, maybe BSON. And then if you have the bandwidth to develop the application, basically, I think the protocol buffers and thrift are also not bad because like Karthik and Akanksha was saying, they basically generate the whatever the classes based upon the
Yeah, you can maybe instead of even saying SDK, you can say the client stubs, right? Basically, skeleton stubs are generated by default, and then you would probably implement, okay, which method you need to call, what based on your business logic, right? So rule of thumb, all this, right? Like generally, any B2C service that you expose, when I say B2C is business to consumer transaction, you tend to keep it in JSON structure. Right? Let's say if you're exposing a SDK or API and stuff, any B2B kind of a thing where machine-to-machine communication, business to business, or any kind of thing, you can, if the latency requirements are higher up, high throughput, and the payload size might be even bigger in B2B transactions, right? Like then you can probably look at protocol buffer at some point, but always start with like, JSON, right? Of course. And then as you tune it, iterate it, you can probably look at product.
Yeah, so far I've not worked with thrift. So
one thing to mention is for JSON is as a rule of thumb, like in production environments, we should always remember JSON doesn't use versioning, and thrift and protobufs, they use versioning. So if somebody is asking us why would you use one over the other, that is also one of the key things to remember.
Good point. Sure.
Well, you can offset those things. By default, it doesn't bring, but you can offset those by your signature, the URL context of your API, right? That's how everybody does, right, today, because JSON doesn't bring that capability. But you can offset that by your URLs, right? Like V1 version 1 on the API and stuff like that. But what specifically those things bring is like, you can tie them, marry them together, right? Okay, this context, of course, you're going to have to define that context, right? This context, this URL context, okay, version 1 user, API, whatever, right? API user, you can marry saying, okay, version 1 of the IDL is linked to this particular service URL, right? So that way, it's from a code readability, maintainability, it's easier. Rather than in JSON, you need to figure it out and you need to look a little bit every.
But why would you need versioning at all, right? Unless if you want to be forward compatible, you anyway, whatever you introduce, you have to make it such that it is optional, right? Unless you are changing some breaking changes, like you are removing a required field or something, that's when versioning matters, right?
In real projects, when you are implementing your thrift definition, there will be number of changes, and you will be asked to change your protobuf definition or thrift definition.
You will end up always breaking it.
Yeah.
I know, like backward compatibility, forward compatibility, it's all nice for small changes, any patches, right? So it just follows a semantic versioning, right? Major, minor, and patch. Any patching that you do for hotfix or any minor changes, you'll support the backward forward compatibility. Most likely it will be breaking changes. That's why you need versioning capability, because we have different versions of API too, right? More features. With more features comes the functionality changes, and you would break it. So that's why the versioning helps, kind of.
Yeah, I mean, if you are kind of redefining the entire model, then your application also has to change. It's almost like a new service you're writing at that point. I don't know. Yeah. Okay.
Yeah, of course. So any new version will mandate you to write a new service, obviously, right? I mean, there are some ugly ways to do it as well, where somebody, oh, this particular parameter comes, then you use the different version of the request structure call. It's generally not advisable, but yeah, people do that too. But general rule of thumb, when you define a new schema, most likely you'll tag along with a new service definition, like completely new service URL context, right?
Yeah. Okay. I think we are about time, right?
Yeah, we are.
I will
So
update the notes for the encoding and in this chapter. I started it, so I will catch up.
so
Hey,
we're
guys.
leaving off here. Dynamic systems.
Wanted to let you all know I'll be leaving to India on June 3, so might be I'll skip here and there few ones, but I'll catch up on YouTube videos.
Oh, okay.
Okay.
Have
Yeah,
fun.
no worries. Yeah, have fun.
Cool.
Yeah, for sure. Okay, so we'll go ahead and resume this section next on Friday. And I think before that, continue to review this chapter. There's a lot of technologies in here that probably need to just spend some time looking at, or just maybe do like a crash course YouTube kind of walkthrough just to get the basics. That way, like, we all can kind of speak more intelligently about it, especially if we don't have experience with it. Just kind of look at what these technologies are. And then that's pretty much it. Yeah.
Okay.
Good job, everyone.
Thank you. Bye.
See you all. Bye.
Thanks, Ramya.